Well, good morning. I think most of you weren't already here when I said good morning, but good morning to those that didn't hear it. Well, hopefully you're here, either interested in hearing me talk or interested in Java about education, or the difference between Java and education and the Java that, well, most of us use. And are we good to go? Okay, I think it's 9 o'clock sharp, so I guess let us get started. So again, good morning, everyone. Thank you for coming to my TED Talk, I guess. So I'm here to talk about the Great Divergence. It's kind of a catchy, verbose title looking at it, but it's mostly talking about the widening gap between industry and just university Java. And feel free to follow me on my socials as well, free promo over there. But a little bit about myself. So I'm Felipe. I am currently a third-year student at the University of North Carolina at Chapel Hill over in the US. You can probably tell by the accent. If you don't know much about the school, it's where Michael Jordan went to school. And also, I'm a student at Duke University as well, also doing a computer science major. I'm able to be part of both schools because of the Robertson Scholars Foundation. They're kindly sponsoring me to come to this talk and, well, be here with you guys, so I'm very thankful for them as well. With regards to my technical experience, last year I was an intern at Amazon on the retail side of things. I was working on their product pipeline, and this summer, like 3 days from now, I'll be starting work at Google on their Google Core ML team. Surprisingly, I'm not doing any ML, but the name of the team is Core ML. With regards to my experience with teaching, so I'm a teaching assistant to a software engineering class with over 180 students. So this is the first iteration of the course. We thought that there was a lack of a software engineering standpoint within the university curriculum, and we thought about offering a class. So I was a teaching assistant for the first offering on this class, along with the professor and other teaching assistants. I hosted over 6 workshops, gathering a total of about 100 students, teaching them about Java technologies such as Quarkus and JBang. And I'm a published researcher focused on improving educational software. So one of the things that I do is I work on software that helps faculty and professors keep track of how their students are doing in the class, in the assignments, what are concepts they have difficulty grasping on, based on the results from their code or their grades within the class. But, well, we're not here to talk about me. We're here to talk about Java. And if you're here at Vox UK, I assume you have a deep passion for Java like I do, but I think that the Java that you, fellow Jedi Masters, are used to seeing is very different from the Java that us university students get to see. and I think that this gap is not something that is sustainable or good in any way. And I think it's sometimes, well, not assuming anyone's age, but it's been a minute since you went to university and saw the way they're being taught. And back then, Java was a very modern and considered a very modern language and new, with concepts such as object-oriented programming, and I guess just the structure of it wasn't a big deal back then. But now, I think there's a lot of stigma towards Java. And in this talk, when I talk about other languages, I'm not trying to bash on them or say that Java is better or worse than any of them. I'm just simply trying to say that Java is weighted differently than all the other languages, and I think we can do something about that. And when I say bashing, I don't include JavaScript in that. JavaScript is just bad. But so to start off, I would like to talk about industry, because I think that's what most of you are familiar with, right? So Java in industry is very much modern. I think Java 20 is the latest version, with 21 coming out. Virtual threads, a very exciting new feature. But most of the stuff is included not necessarily in Java 20, but have been ever since Java 17 and so on and so forth. Exciting things are just pattern matching, text blocks, and sealed classes and interfaces are all assigned features that were included in previous versions but are now being included, which just shows how the Java community is excited and is looking forward to making Java adaptable and making sure that we're keeping up with industry trends. We're not just setting a static level to the language. We're making sure that we're doing everything we can to keep up with whatever else is out there. And so it's probably no news to you that Java is very much used in industry. Microsoft has more than 500,000 JVMs in production running hundreds of internal Microsoft systems. And the article that I got this from was from around 2014. And so ever since, I think from an anonymous source, that there are around 2 million JVMs currently running within Microsoft. And it just goes to show that Java is very much alive. And so every time you hear Java is dead, I'll post the slides and you point them to this article. And that's not only at Microsoft. Other big tech companies also adopt Java as a language. So again, from an anonymous source, Google Suite, the Docs, Sheets, and Calendar, most of these things are written in Java. And people like to think that, nobody uses Java anymore. Java is just legacy code. And yet, these fairly modern things are all based on the idea of Java. Amazon.com. Recently, so mostly within their retail side, also from an anonymous source, are mostly involved with Java. But even then, on the AWS side, James Gosling just got hired by AWS to work on their Amazon Corretto release. And based on some news, I think Java Corretto jumped to about like 30% of the market, which is comparable to the Oracle JDK. So they're really pushing and making an effort to include and invest in Java and Java developers. And Twitter, Elon Musk famously leaked the algorithm for recommendations within Twitter. If you looked at the programming language breakdown, we had about 40% Scala, which is essentially functional Java, and about 20% Java. And then, again, these are things that we considered modern. And famously, LinkedIn, they recently posted an article on Twitter about how their upgrade from Java 8 to Java 11 and the GC optimizations really improved their performance when it comes to just scale and overall throughput. And LinkedIn was in Java 8 up until, I think, about a year ago, and they migrated to Java 11 now. Wait, raise your hands. Who is in Java 8? Using Java 8? OK. Fair. I feel your pain. Java 11? Good. 17? Nice. 17 plus? Nice. OK. Who's on something lower than Java 8? Great. I feel bad for you, but that's OK. And again, this is not limited to just big companies. I think Lufthansa, German airline, they're also using Java, but not only just plain old Java and Spring, which we usually associate with, but Quarkus. Quarkus is the new framework from Red Hat that presents a lot of new features that we usually associate with languages such as Python and JavaScript. And it goes to show that companies are keeping up with what's new in industry, and they're implementing it within their own systems. But also Banco do Brasil. So I'm Brazilian, and this is one of the biggest and oldest, I think the oldest bank in Brazil, and they also implemented Quarkus within their systems to optimize their performance. And Vodafone, I think UK-based telephone company, is also using Quarkus within their system. And actually, Quarkus has, within their page, just a user story page where they list all the companies that have user testimonies of using Quarkus and seeing amazing benefits compared to what they were using before. Now, this is all nice and good. We can see that the industry is keeping up with Java, and Java is very much dominant in industry, I would say. However, this is from GitHub's Octoverse graph, which shows the usage of languages from about 2014 to 2022. I think they didn't run the 2023 version yet, but you can see, and I think if you did this graph 10 years prior, Java would be at the top, completely dominant. I think Java for a long time was the standard in industry, but ever since it has gone down. So much so that JavaScript has been the leading language for about 10 years, and Python is just now increasing. TypeScript impressively did a lot of leaps and bounds, but Java is continuously decreasing, even though industry, again, is very much interested in Java. And I'm a curious person, and I always ask myself, why is that? Why is it that even though we have all these people at DevOps UK that are interested and passionate about Java, why do we still see this decline in the language usage? And I think as a university student, I had a unique perspective with that. And so I'm here to tell you a little bit about the way that Java is being taught at universities and why I think that we saw the changes that we in the graph. And so the first thing to say is that universities are moving away from Java. So first of all, this is an article from the ACM, so the Association of Computing Machinery, I believe, and it shows the amount of university courses, intro-university courses that are taught in Java versus other languages. So who here was taught like your CS 101 first programming course in Java? Okay, let's say have Python? Or something not Java or Python? Okay, good. I would say most of you were taught Java back then, and I think that's the common thread that I see among people from industry, right? If they were in university when Java happened, they mostly had Java as introductory course, but if you were there prior, you were very excited about Java, but wasn't necessarily taught Java this way. But now, as we can see, the trend is starting to go towards Python, and a lot of universities are migrating from Java to Python. And I'm not saying that's for a bad reason, but I'm just letting you know it's happening. And so I'd like to point out an example from my school. So at the University of North Carolina at Chapel Hill, the first course in programming is Comp 110, and we're using Python 3.11. And 210 is our data structures course. This is the next course in the sequence. We're using Java 14. At the time I took it, hopefully they're using 17 now. Also 301, which is our object-oriented programming course, taught in Java 8, 11, depending on the faculty that you get. 211, which is our systems course in C. The architecture course in C MIPS. And lastly, the CS theory course is also taught in Java. For some of the programming assignments, most of the CS theory course is just drawing little state machines. But this is the basic intro sequence. And again, most of it, where the parts that they could, they're using Java. But for a little while now, they transition intro to programming into Python, and they're thinking and discussing about future changes to the curriculum based on language structure. But what is happening? Right? So in seeking to know more about what's happening with Java, I helped to teach a class, as I mentioned, Foundation of Software Engineering, over 180 students and taught in Python. This was not my choice. No, I'm kidding. But Python is a great programming language as well. But this just goes to show, again, that for a long time, Java was the standard, but now it's starting to lose its ground a little bit. And again, there are reasons why. And in this class, I ran a lot of surveys about what are the things that students think about Java. And I think 180 students is a good sample size, so let's see what they think about Java and its current state in industry. So the first question I asked them was, currently, what language is in highest demand in industry? And out of 188 students, 76 of them said Python was in highest demand, about 42% of the students. And JavaScript was ahead of Java, about 24% of students, and Java itself was about 21%. And if you look at a graph, it kind of makes me sad of it, because I do like Java a lot, and I hoped it would be the yellow bar. But this just goes to show that the perception that we have of Java is not necessarily the perception that students are having of Java. And there's a lot we could do about that. When it comes to what language would you use to build a REST API within a software engineering course, and I think that Java is what you'd call a backend or a server-side language, which is where our strong suit is. And we see that the overwhelming majority, around 67, rounding up 70% of students, end up choosing to code in Python over Java. And thankfully, we beat JavaScript. But and JavaScript is just as good about the 8% of the other languages, which are like Rust, C, C++, which doesn't tell us a lot. But this is just to show that there's definitely a little bit of bias against Java in these days. And I asked them to rate these languages from modern, not modern, to modern on a scale from 0 to 100. And again, Java came far behind. And again, Java is around 28, 27 years old now. Python was released 5 years before Java. So about like 30-ish years. And again, a modern is not necessarily a metric of like, oh, how long has it been since you've been released, but a metric of how we've been evolving. And for some people, the idea that Java is evolving is, well, they think that's just not happening. But I think, again, this is a misconstrued view, right? Java has like version 20. Python, well, I guess the numeration in Python is different, but, and so, rate how likely you would be to find this language in a modern company's tech stack. And this is a promising one, though. So they said that Java would be about 78% likely, and Python and JavaScript would be the ones you would be most likely to find. But there are a lot of, I asked for their written feedback as well, and there's a lot of interesting quotes that I think will be enlightening in this case. And so do remember this graph as we move on. And I also asked, which programming languages have you used to make a personal project? And this is like, you can write multiple ones. And so given that Java is what they use for most of the object-oriented programming language, I was happy to see that 60% of them use Java. But again, Python is the overwhelming majority. Not overwhelming, but the majority. And I also asked them to describe Java in one word. And I did this, and I grouped them into groups, and I think that I'll just share with you what they said. So the first and most common one was, Java is tedious and boring. Now, I'm a little bit hurt by this statement because I think Java is one of the most fun ones to use. But again, the idea that Java is tedious and boring, and I didn't have the opportunity to go and talk to them about why they think Java is tedious and boring, but I think this has a lot to do with the idea of boilerplate code and having to write your classes, but also the fact that they write plain Java programs, which don't have necessarily the functionality and the scale that you usually see on your social media with like Python and JavaScript. You know, if you open your Twitter account, and I'm in the Java circle mostly, but most of my friends that are within the general COS curriculum, they see a lot of React and a lot of like hooks and all these cool things. And you know, when it comes to Java, all they learn about are classes and interfaces, which I believe you don't come to appreciate until you have to deal with a large-scale problem, and the rigidity that the structure provides to you is actually very helpful when looking at other people's programs. If you ever worked in Python before, when you're looking for a class, there's a chance this person wrote 5 entities within the same class, and you have to go like command Fing through, whereas in Java, it is fairly easy to tell how and where the program is structured. And the next one, I think will come as no surprise to anyone, is verbose. Verbose is also part of the overwhelming majority of responses. And again, this is not surprising. Java is a bit wordy. You do have to write a little bit, but and compared to like Python, which is very simplistic. But again, this is not a bad thing about Java necessarily. It's just one of those things that you only come to appreciate when you really have to use Java in a large scale. Once you're just beginning to program in Java or beginning to program at all, you really don't appreciate the rigidity that the public class X and then the public static command void statement does. And another one is outdated, right? So they think Java hasn't gotten an update in a little while. And whereas other languages are migrating towards a more simplistic, succinct, functional point of view, they think Java just hasn't done that at all. Which, again, if you're keeping up with industry, I think Java is one of the communities that really pay attention to its users. Like Lambda's added in Java 8, the Flow API, I believe in Java 11, and all these things are what we call modern programming paradigms, and they follow a certain functional style as well. And so usually we associate functional with JavaScript, but I think Java does a good job of looking at these new features that are coming out and seeing how can they be implemented within Java and making sure that our developers also get the best experience when creating their programs. And another one is bloated. And I think this mostly has to do with the fact that they think that Java, you have to create so many classes. It's one class for every it's one file for every class, so forth. It's not succinct, so it makes your programs bloated. Actually, I think Java is not bloated at all, and now with GraalVM especially, I think there's a lot of potential for making things much lighter, faster, and better. If you want to learn more about GraphVM, you should attend Alina's talk today, later today, and on Friday, I believe. And now I would like to show you a quote that I found within the responses about it. It was an optional response, so if they had a strong opinion about Java, they could write something. The majority of students didn't write anything, but some of them did. So when it comes to Java, the student said, I think that it's probably good for helping to maintain legacy code, but I would pretty much choose any language other than C to work in besides Java if I had the chance. So they basically think that no one that writes a new program these days will write it in Java, and Java is pretty much an old standard that people just have to put up with. And again, as a person that likes Java, this hurts a lot. And also, they grouped Java as in they could rank all their languages like Go, Rust, Swift, C++, and they said they hate C the most, but Java is just one on top of that. And so you can stack up all the other programming languages on top, even Swift, which is fairly new and modern. And the question is, why are we seeing this? And I think it has a lot to do with what's so-called the on-ramp. So who has heard the term on-ramp before? So when you're talking about the on-ramp, it usually refers to the process of like learning a new language or learning a program at all. So how does the on-ramp into learning and mastering this language goes, right? And so you could imagine something like this, right? You have a big hill, and you're pushing this big red ball up the hill, right? And this looks like a dire task, depending on what material the ball is made out of, impossible if not. But it seems like it's a challenge. Learning a new program is a challenging task. Learning a new programming language is a challenging task, but it seems doable. And I think that's what Python looks like, right? The syntax is simple. There's not a lot of rigidity. I mean, you do have to remember your white spaces, but other than that, it's pretty much you create a file and just start typing away. And I think that the problem with Java is when students first see a hello world program in Java, they think of it like this. It's very hard to get started and to learn. And there are ways to go around it. You could look at a program and say, who cares about a class? Why does it have to have the same name? It's okay. Just ignore all of that and just look inside the main method. And it's, I think there's a lot of hand waving, and at least at university we call that magic, right? It's a lot of magic. You learn about this later on. But especially if you're curious and an engaged student, you want to know why people are doing things the way they're doing things. And I think something about being passionate about something is understanding how it works. But how can we expect new students to be passionate about something they don't really understand, right? And so I think that's one of the big reasons Java is this way. And so, again, and people think that no one really cares, like new students, they should just learn what a class is beforehand. And I think that's not the way we should go about it. And it's good to see that the Java community is also thinking that way. And so to start off, this is what you would see your usual hello world program is. So public class, hello world. Again, what does public mean? What's a class? Public static. Static keyword is one that gives students a lot of trouble. What's the difference between a regular variable and a static variable? Also main, why does it have to be called main and not something else? Why can't I just run the file and just runs everything in it like Python does? Why do we have to pass an array of strings as your arguments? And again, what is system? And what does out means? And why do we have to add the little ln at the end? These are all things that people usually, gripes that people have with the language. But not for long. And I think that if you are keeping up with the current trends in Java, you've seen the on-ramp article by Brian Gutz talking about how can we get Java from this to this. And JEPs are Java Enhancement Proposals, I believe. They're short for Java Enhancement Proposals. So there are two new JEPs within the Java community, and they're attempting to transform Java from this to this. And again, this might actually be sound really terrible for you because it provides a lot of flexibility that you usually don't want, right? So you want something that is rigid so that you can make sure everything follows the same format, and it prevents you from doing bad things. And one of the things about making this change, there's a lot of potential for allowing people to just, break things. And and Brian Vermeer, I think his talk is already gone, but you should go talk to the sneak booth with him, spoke that there's a difference between what's intended to do with a new proposal and what actually happens once you release this proposal. And so that's something we have to do very carefully, but it's something that I'm very excited about because I believe this is a game changer for Java when it comes to learning. Yes, you do have to know what void is. You do have to have a main method, but I think it's much better than what we had before. And again, it helps with taking away a bit of the magic and the hand waving that you usually see within Java. And so those were mostly gripes about the Java language, right? But when you think of Java, the thing that comes to me is not necessarily the Java language. Yes, I do love Java. I like programming in Java. But I think Java is much more than the language. I think Java is also about community and the features that come with it. And so I like to think of Java as mostly an ecosystem, right? The reason why we like to attend these events is because to meet people that are working in Java and excited about it and are proposing to us the latest and greatest and newest features and the little projects, open source projects that they use to make our lives better. And so things like SDK-man, JBang, Quarkus, GraalVM, these are all things that are coming along in the Java pipeline that help us. And this is, again, Java is not in a vacuum. It's not isolated. It's actually been used by others, and people know where when its strengths and weaknesses are, and they're working on making sure that we can get the best out of Java. And so it all comes down to tooling in a sort of way, and this is not something that you see when you're in university, right? When you're in university, you're just worried about classes and interfaces and make sure how you learn to program, and you don't really think about the tools that make this language great. And I think for languages such as JavaScript and Python, you do get a lot of the tooling built in. But I think that Java, one of its strengths is community, but it's also one of the weaknesses in a sense that they're not built in straight into the language. There's something that you have to go and like, who here, for example, has heard of SDK-man? Okay, right? So when I was taught Java for the first time, my dad, also a Java developer, had to help me install Java because the Java installation process back in the day was a little bit painful. There were a lot of Java websites with different SDKs, JDKs. You don't know where to download things. SDK-man really provides a good way to do things, and especially like installing something with SDK-man is a simple curl command away. And now it's the time that I start praying for the demo gods. But so if you, for example, I never used SDK-man before, you can simply do like SDK, and it runs the command. You can install anything such as that, but you can also do SDK list Java, and it lists all the distributions of Java for you to see. So 8 up until 20, Amazon, Glue and GraalVM, lots of versions of GraalVM, Java, .NET, and then also there's an Oracle distribution at the bottom. But installing Java becomes really easy, and it actually maintains all your Java distributions over here. And then, yeah, so these are the current Java distributions that I have right now, and it also makes it very easy to change your Java version. Now, I'm currently on the Microsoft version, and because I practice with the Microsoft version, I'm not going to change Java versions right now, but not that it would change anything, but just for a little bit of luck. But you can change the distribution you use by like using SDK, use Java, and then whatever distribution you'd like to use. But then again, this makes it very easy and simple to install Java, and it's much better than the process that you used to have. But then again, it's not necessarily built within the language itself as a tool wrapped around it. And in addition to that, we have a couple of other features, such as Visual Studio Code, which is open source as well. But one of the really good things about Visual Studio Code is not really related to Visual Studio Code. It's about containers, right? So I think most of us have seen or heard about containers or used them in our jobs. And containers are exciting for distributing applications in a packaged way, but they're also very good for teaching students. And one of the biggest challenges when it comes to teaching in general is the differences in systems, right? If you have a Linux computer, that's like 1% of the student population, I would say. If you have a Windows, if you have a Mac, it makes it very hard if you haven't updated your software in a while to make sure that we all are on the same version, especially with something like Java, where you can see where you had all these distributions. And so making sure that we're all on the same version is rather difficult. And so containers provide a way for students to actually go and see and have the same environment. And VS Code has a feature called dev containers, which allow you to code inside of a container through VS Code. And it's actually a very nice and seamless process. And I had a demo scheduled for that, but downloading container images is very difficult on a hotel Wi-Fi. And so that has been postponed. But it's a good feature and something that you should try. So our class, our software engineering class, is all run within a dev container. And so we install all the required features in there. And so students never run into the problem of like, oh, this command is not working on my machine. Everything works once you're in the container and using the terminal in there. The problem is Docker is rather flaky sometimes, especially on Windows. But other than that, it's a really smooth transition. But another exciting feature is JBang. So who here has used JBang before? JBang? OK. So JBang, I guess if you're already in industry, is a bit harder to use just because it's mostly an intro feature. It does allow you to build project with Quarkus and create some Java file structure that you'd like. However, JBang, so the way that you usually use Java is you create like a main.java file. You have to import your java.lang.system.out, and then you have to do all the boilerplate stuff. Slow static void main. IntelliJ makes this very much easier with PSMB if you use IntelliJ. And then you do out.println. Hello, and make sure I'm spelling it right, Box UK. And so the way that I guess we're taught to run a Java program if you're not in an IDE is you have to do Java C, main.java. Oops. Can I find symbol? Oh yeah, sorry. Good catch. Thank you. The demo gods are, you are my demo god today. And so, okay, and then you run Java main and you see hello devox UK. So that's a two-step process. Whereas with Python, you just run it on a single line of code, which is like Python M and then the name of your file. But again, this is a rather troublesome process because there's a lot of magic involved. First of all, what does Java C even do? And also, when it comes to Java, like, why do you have to have a two-step process in order to run something as opposed to Python, where it's just so easy, right? And then you have to explain what Java bytecode is to someone that barely knows what a variable is, right? They're writing the first program, they're printing stuff, they're doing their little hello world program, and they have to know about all these things. JBang makes this much easier. So if you do a JBang init hello.java, and then you can actually just run this as an executable, and it just runs a hello world, but also you can do like JBang hello.java, and it runs the same thing. And if you open your hello.java file in JBang, you can see you have all the same dependencies, and these look like pretty much the same. And again, we can change this, say devox UK, and then you don't have to do anything. It will build the jar for you, and we'll run it. And this is for cool little projects, especially introductory courses. I think this is a really nice tool that helps students use Java. And JBang actually automatically installs Java, so JBang is installed much in the same way the SDK man is used. But you can also use JBang to start based on other templates. So there are a lot of configurations that you can use. So this is not necessarily something that only university students get to use, but also other people in the industry. And in addition to that, we also have really cool, interesting features with Quarkus. So I mentioned Quarkus a lot within this talk. So who here has heard about Quarkus before? Nice. Great. So that's a really nice and exciting feature. And I think we have enough time for a little demo on Quarkus. So Quarkus is a framework much like Spring, but it's built by Red Hat, and one of the really, really exciting features about Quarkus is dev mode. So what is dev mode? So who here has worked on JavaScript, Python before? So if you worked on something like that, you usually get, when you're building an API, something like hot reload, right? You don't have to go and stop and run your program again. You can actually just change the files, and the server will automatically restart, refresh with new changes. So with Quarkus, create app, hello, right? You can actually do the same things. And it looks like something like this. And that, we just do an idea. And it actually is very easy and exciting to use Quarkus because it makes the process so seamless. And I love Spring as well, but I think that it lacks a bit when it comes to just feeling like, for example, if you used Python before, and I try to tell my friends, okay, you're building an API with Python, let's try to build one with Java. And they have to stop and start the program within IntelliJ, within VS Code, and it says it feels kind of clunky, especially once you have hot reload. Going back to normal execution is a bit hard. But if you go over here to your terminal and you go Maven Quarkus dev, it will automatically start for you. It's actually very fast. My machine is just running a lot of things right now. And so, like, again, 2.3 seconds, very fast, and the application is already running. So if you go to your hello endpoint, you get the hello from REST Easy Reactive already in here. And again, this is a very exciting feature. And now, especially if we want to change things, let me say DevVox UK, we can come here, save, and when we ping the endpoint again, we already see the changes. And again, we didn't have to restart our program at all. Actually, you can already see that it automatically refreshed for us once it saw the file changes. And again, this is a very exciting feature and makes it very easy to Java to use and very exciting. So when someone is using Python, especially students, and now let's say, well, let's use something like Java, the idea that Java is old is really easy to see it that way once you go from like fast API to something like Spring, where you have to stop and reload your application. But when it comes to Java and Quarkus, it makes it really easy to make that transition. And I think it makes the Java scene on a better light. And lastly, the feature it comes with is GraalVM. So GraalVM is so usually when you're using Java, using a virtual machine that does JIT, just-in-time compilation, but GraalVM actually does a lot of optimizations with ahead-of-time compilation, analyzing your code, making sure that we can optimize it and make sure that it runs a little faster. It's also native, so you can run straight into binary. And if you're actually building a lot of command line applications lately, and you can tell the difference when you're running like a Java jar versus a straight up native compilation binary, which makes the experience really much faster. It's like noticeable how fast and how good this program is. And this goes to show that, again, the Java community is looking at the things that are happening with the language, and we're trying to make sure that we do our best that everyone within the communities is seeing like the modern and most exciting features. And again, if you'd like to see a GraalVM talk, Alina, this afternoon and Friday, yes. Right? Okay. And this leaves the question of how can we help, right? So seeing these things, it's hard to be skeptical, especially with the graphs, but there's actually a lot we can do to help. And Java is all about community, in a sense. The people that you're around really help you and shape the way that you think about certain things. And so community is a great way to impact and lead others. And I'll start with some quotes to introduce some thoughts that are going on within the Java academic side. So I think Java is good to learn the important CS concepts, but around here, UNC computer science doesn't really show me how it's applicable in the real world. Now, again, as I mentioned, when you start working with Java in university, you're learning about classes and interfaces, and once you get to industry, there's a lot, like you have to learn how to use the command line, you have to learn how to build a REST API, what a service is, and those are not necessarily the things that you taught back in your introductory course that I showed you. And that's where guidance comes in, right? When you, again, if you're on your regular social media circles, it's much nicer and easier to see the new Python machine learning application with TensorFlow or the new React app that you build really easily. But when it comes to Java, you don't see it that often. And also, I think Java, in my experience, is a great language to learn programming foundations. But from my job and internship experience with the other senior devs, it seems Java is a little outdated. And again, this begs the question of who are they talking to, right? So what are the developers that they're reaching out to, and what are the things they're learning within their job? So they're learning within their job that Java is outdated, Java is only used in industry because of legacy. No one these days builds a modern app with Java anymore. What is Java?